First of all, we will revise algebra part. Question number 1. The additive identity in Q is 0. But the multiplicative identity in Q is 1. Number 3. If 4 minus x over x plus 5 equals 0, then x, when I say a number, a rational number equals 0, so the numerator must be equal 0. So 4 minus x must be 0. Then x equals 4. To be 4 minus 4 equal 0. The additive inverse of the number absolute value of negative 3 over 5 is, first of all, you have to find the absolute value of negative 3 over 5. The absolute value of negative 3 over 5 is 3 over 5. And the question is, find the additive inverse. The additive inverse of 3 over 5, additive inverse means it changes the sign. So 3 over 5, its additive inverse is negative 3 over 5. The median of the value 75491. To find the median, first arrange the values ascendingly or descendingly. So I'll arrange them first. 1, 4, 5, 7, 9. The middle value, the value which lies between them. So it's 5. The rational number lies in halfway between 1 over 3 and 5 over 9 is, to find the rational number that lies in halfway between 1 over 3 and 5 over 9, you have to make greater plus smaller times half. So 1 over 3 plus 5 over 9 times half. You will get 4 over 9. So the rational number that lies in halfway between 1 over 3 and 5 over 9 is 4 over 9. The remainder of subtracting negative 2y from 4y is, when I say subtract from, it means the second minus the first. So the second is 4y minus the first is negative 2y. 4y minus negative 2y, negative times negative, it will be positive. So 4 plus 2, it will be 6y. 10x barred by 2, y bar 3 plus 5x y bar 4 equal 5x y bar 3 bracket. In this question, he wants to find the HCF, to factorize this expression by identifying the HCF. And the HCF is 5xy bar 3. So you will divide the expression by the HCF. 10 divided 5, it will be 2. X bar 2 divided x, x. Y bar 3 divided y bar 3 cancelled each other. Then 5 divided 5 is 1. X divided x cancelled each other. Y bar 4 divided y bar 3. When I divide, I subtract the power. So it will be only y. Number 9. The number that hasn't a multiplicative inverse. The only rational number that hasn't a multiplicative inverse is 0. Because it's 0 over 1, I can't say 1 over 0. 1 over 0 is meaningless. Question number 2. Use the distribution property to find the value of 22 over 25 times 7 over 11 plus 22 over 25 times 5 over 11 minus 22 over 25 times 1 over 11. Look, 22 over 25 is repeated. So take it out. It will be 22 over 25. Then open bracket. When I take 22 over 25 out, and you will write the remainder inside the bracket. So 7 over 11 plus 5 over 11 minus 1 over 11. Bracket first. So I have 22 over 25, drop it, times. When you find the value of this numbers between the bracket, you will find it equals 1. So 22 over 25 times 1 equals 22 over 25. Now let's move to question number 3. The question is, find 3 rational number lies between 4 over 7 and 3 over 5. These 2 rational numbers have different denominators, so I have to unify denominators. 4 over 7 and 3 over 5. 4 over 7 and 3 over 5. We will multiply 7 by 5, up and down. And multiply 5 by 7, up and down. 4 times 5 is 20. 7 times 5 is 35. 3 times 7 equals 21. 5 times 7, 35. So I have to find the 3 rational numbers between 20 over 35 and 21 over 35. There is no rational number between them now. So multiply by 10, up and down. It will be 200 over 350 or 210 over 350 if we multiplied by 10, up and down. So the rational numbers are 201 over 350, 202 over 350, 203 over 350. Okay? Let's move to question number 4. Factorize by identifying the HCF. 6x barred by 2y bar 2 minus 4x bar 3y bar 4 plus 2x bar 2y. 6, 4, 2, all of them are divisible by 2. So take 2 out. X bar 2, x bar 3, x bar 2. Take the repeated symbol with the smallest power. So x barred by 2. The same in y bar 2, y bar 4, y. So take y. This is called the HCF. So you have to divide all the terms of the expression by 2x barred by 2y. 6 divided 2 equals 3. X barred by 2 divided x barred by 2 cancel each other. Y bar 2 divided y, you will get y. 4 divided 2 equals 2. X barred by 3 divided x barred by 2, you will get only x. Y bar 4 divided by y barred by 3. Don't forget, in dividing we subtract the power. Plus 2 divided 2 equals 1. X barred by 2 divided x barred by 2 equals, cancel each other. Y divided y, cancel each other. So you have to write 1. Okay? Now let's move to number 2. In the same question, factorize by taking out the HCF. Now look, we have a repeated bracket. This is the second type in HCF. If you have a repeated bracket, take it out. X plus 5. Then open another bracket. When we take x plus 5, so you have to write 2x minus. Take x plus 5 out. Drop negative 3. Now we have finished the question number 4. Let's move to question number 5. Question number 5. Subtract negative x bar 2 minus 4x minus 7 from x bar 2 minus 4x minus 2. When we say subtract from, means the second minus the first. So write the second expression first. Then write the first expression under it. In subtraction, don't forget to it changes the sign of the second expression. Negative, it will be positive. Negative will be positive. Negative will be positive. So, it changes the sign of the second expression. X barred by 2 plus x barred by 2, it will be 2x bar 2. Negative 4x plus 4x, you will get 0. So don't write anything under x. Negative 2 plus 7, it will be positive 5. So the remainder is 2x barred by 2 plus 5. Okay? Let's move to question number 6. Add 2x plus y plus 5 and 3x plus 2y minus 1. When I say add, it means plus. So 2x plus y plus 5, 3x plus 2y minus 1, I will add them. 2x plus 3x, you will get 5x. Positive y and positive 2y, it will be positive 3y. Positive 5 minus 1, it will be positive 4. Okay? Let's move to question number 7. Divide 15a powered by 2b power 3 minus 10a power 3b plus 15ab by 5ab. When I say divide, it's dividing an algebraic expression by a monomial. A monomial means an algebraic expression consists of one term. So, 15 a power 2 b power 3 minus 10 a power 3b plus 15 ab over 5ab. Now let's divide. Divide the number by number and the symbol by symbol. 15 divided 5 equals 3. A power 2 divided a. When I divide, subtract the power. So a power 2 divided a, you will get a. B power 3 divided b power 1, you will get b powered by 2. Plus, minus negative 10 divided 5 is 2. A power 3 divided a, you will get a power 2. B divided b cancelled each other. Then positive 15 divided 5, you will get positive 3. A divided a cancelled each other, and the b divided b also cancelled each other. Now, question number 8. Divide 3x barred by 2 plus 2x minus 8 by 3x minus 4. It's dividing an algebraic expression by a binomial. So, you have to make a long division. 3x barred by 2 plus 2x minus 8 by 3x minus 4. When we divide an algebraic expression by a binomial, we follow 4 steps. Divide, times, minus, drop. First, divide the first term by 3x. 3x barred by 2 divided by 3x, you will get x. First, we divided 3x barred by 2 by 3x. The result is x. Then multiply. We have to multiply x by 3x minus 4. So x times 3x is 3x barred by 2. X times negative 4 is negative 4x. Then subtract. Subtract means it changes the sign. So it changes the sign. This will be negative and this will be positive. Cancel each other. 2x plus 4x, you will get 6x. And then drop. Drop negative 8. Repeat it again. Divide times minus drop. 6x divided 3x, you will get a positive 2. Then multiply. 2 times 3x, 6x. With 2 times negative 4, negative 8. Change the sign. This will be negative. and this will be positive. Cancel. So the quotient is x plus 2. Okay? Now let's move to question number 9. Simplify to the simplest form. 2x minus 3 bracket 2x plus 3 bracket plus 7. First, we have to simplify the two brackets. Find the value of two brackets. Two brackets the same except the middle sign. So it's the third special case. So first times first and second times second. 2x times 2x, you will get 4x bar 2. Negative 3 times positive 3, you will get negative 9. And then drop positive 7. The question is simplified to the simplest form. So I have to simplify this expression to the simplest form. 4x barred by 2 drop. Negative 9 plus 7, you will get negative 2. Finish. Number 2. 2 bracket x minus 3 and 5x minus 2 between bracket. First, we have to simplify the bracket. X times 5x, we will follow the rule, first times first, second times second, product of means plus product of extremes. First times first, x times 5x, we will get 5x barred by 2. Negative 3 times negative 2, don't forget, negative times negative is positive. 3 times 2, you will get 6. Then, multiply the extremes and the means. X times negative 2, you will get negative 2x. Negative 3 times 5x, negative 15x. Negative 2x and the negative 15x, you will get negative 17x. Then we have to multiply 2 by each term of them. 2 times 5x bar 2, you will get 10x bar 2. 2 times negative 17, negative 34x. 2 times 6 is 12. Now it's finished. Let's move to the last question. Find the mean of the values 2, 3, 5, 6. To find the mean, add the values and divide them by their number. Sum of values over their number. So to find the mean, add 2 plus 3 plus 5 plus 6. 2 plus 3 plus 5 plus 6 over their number. They are 4 values, so divide them by 4. 2 plus 3 is 5. 5 and 5, 10. 10 and 6, we will get 16. 16 over 4 equals 4. Thanks. Second geometry board. Question number 1 complete. The sum of measures of accumulative angles at a point equals 360. If measure of angle A equals 70 degrees, then measure of reflex A. To find the measure of the reflexed angle, make 360 minus 70. You will get 290 degrees. The two line segments are congruent if they are equal in length. So the two line segments are congruent if they are equal in length, but the two angles are congruent if they are congruent or equal in measure. The two straight lines are parallel to a third one are parallel. If you have two straight lines are parallel to a third one, they must be parallel. The measure of each of two equal supplementary angles equals. The sum of two supplementary angles equals 180. But the question here is, find the measure of each of two equal supplementary angles. He wants the measure of each one if they are equal. So you will make 180 divided by 2 to get 90 degrees. The perpendicular bisector of a line segment called The straight line which bisects the line segment from its midpoint, we agreed that it called axis of symmetry. If the polygon ABCD congruent to XYZL, so AD is equal to XL. If two straight lines intersect, I have two straight lines intersect, then the measure of each space are equal in measure. The measure of each vertically opposite angles. So if you have two straight lines intersect like this, so the measure of each of two vertically opposite angles will be equal in measure. Number 9, if AB line segment congruent to XY line segment, it means AB equal XY. So AB divided XY, anything divided by itself, you will get 1. Now let's move to question number 2. In the opposite figure, measure of angle DBC equal 110 degree. DBC equal 110. BE ray bisects angle DBA. BE ray bisects this angle. It's required to find measure of angle DBA. Find DBA. So measure of angle DBA equals 180 minus 110. You will get 70 degrees because they are supplementary angles. And he wants to find the measure of angle ABE. ABE, this one. So measure of angle ABE equal 70 divided by 2. 35 degrees. Why? Because BE bisects the angle DBA. So measure of EBA equal half the measure of the angle DBA. Angle bisector. Now, question number 3. In the opposite figure, if measure of angle AMB equal 40, AMB equals 40 degrees. Measure of angle BMC equal 110. BMC equal 110. Measure of angle AME equals 90, right angle. He wants us to find the measure of angle EMC. The four angles are accumulative at one point, M. So their sum equals 360. He wants us to find the measure of angle EMC. So measure of angle EMC equal 360 degrees minus their sum, 40 plus 110 plus 90. 360 minus 40 plus 110 plus 90, you will get 240. So equals 120 degrees. Don't forget to write accumulative angles at a point. Okay? Now, let's move to question number 4. Question number 4. In the opposite figure, AB parallel to CD parallel to EF. And measure of angle A equals 50. Measure of angle E equals 70. He wants us to find the measure of angle ACE. First, I have BA parallel to CD and CD parallel to FE. Now, measure of angle E equal measure of angle ACD equal 50, alternate angles. And the measure of angle E equal measure of angle DCE, alternate angles also 70. So to find the ACE, you have to add 50 plus 70 to get 120. But how to write it in steps? First, measure of angle A equal measure of angle ACD equal 50, because they are alternate angles. And I have measure of angle E equal measure of angle DCE equal 70. Also alternate angles. Now measure of angle ACE, you will add 50 plus 70 equal 120 because they are adjacent angles. Okay? So first, I get measure of angle ACD equal A equal 50 because they are alternate. Make Z. Measure of angle DCE equal measure of angle E equal 70, alternate. To find the measure of angle ACE, add 50 plus 70 to get 120 because they are adjacent angles. Now let's move to question number 5. In the opposite figure, BC equal EC, BC equal EC, and AC equal DC. Prove that triangle ABC is congruent to triangle DEC. First of all, I have two sides are equal, and I have measure of angle ACB equal measure of angle ECD because they are vertically opposite angles. So I can say BC equal EC side, and also AC equal DC side, and the measure of angle ACB equal measure of angle ECD because they are vertically opposite angles. Now I can say, so triangle ABC is congruent to triangle DEC, which case side, angle, side, two sides and the included angle, side, angle, side. Okay, so in this case we have used SAS, two sides and the included angle, because he gives me BC equal EC side, AC equal DC side, and I get measure of angle ACB equal measure of angle ECD because they are vertical opposite angles. So I can say the two triangles are congruent side, angle, side. Now let's move to question number 6. In the opposite figure, I have AH parallel to BG, parallel to CF, parallel to DE, and AG equals GF equal FE. And it's a given AE equals 9 centimeter. Find AC. He wants us to find the length of AC. Okay? First of all, if I have AH parallel to BG, parallel to CF, parallel to DE, it means AG equals GF equal FE, and AB equal BC equal CD, and AD equals 9 centimeter. I have AD equal 9 centimeters. Find AC. First, I have AH parallel to BG, parallel to CF, parallel to DE. And you can write it from the given. And we have AG equals GF equal FE. So I can deduce that AB equal BC equal CD. AB equal BC equal CD equal 9 divided by 3 because they are 3 line segments. which means each line segment equals 3 centimeters. Now it's required to find AC. AC equals AB plus BC, and we have agreed that each line segment equals 3 centimeters. So I can say 3 plus 3 equals 6 centimeters. Again, if I have AH parallel to BG parallel to CF parallel to DE, and it's given also AG equals GF equal FE, so I can deduce that AB equal BC equal CD. And each one equals 3 centimeters because the length of AD equals 9 centimeters. Now I can say AC equals AB plus BC, and each one equals 3. So 3 plus 3 equals 6 centimeters. Question number 7. Write the cases of congruency of two triangles. We have 4 cases of congruency. Case number 1, side, angle, side. 2 sides and the included angle. And you can write symbols only. Side, angle, side, SAS. Number 2, 2 angles and a corresponding side. So 2 angles and a corresponding side, ASA. Number 3, the 3 sides, which side, SSS. Number 4, right hypotenuse side, RHS. Thanks.